In the beginning, there was nothing. No stars, no galaxies, no atoms, not even space or time. Only a dense singularity, smaller than a grain of sand, holding all the energy that would ever exist. Then, in a moment beyond comprehension, everything began. The Big Bang was not an explosion in space. It was the birth of space itself. Energy erupted outward, stretching the very fabric of reality. In less than a heartbeat, the universe expanded from subatomic size to cosmic scale. Matter and antimatter collided, annihilating each other in bursts of pure light. What remained, a tiny imbalance, would one day become everything: stars, planets, life, and thought. As the newborn universe cooled, it became a sea of particles and radiation. After 380,000 years, the fog lifted. Light could finally travel freely, illuminating a vast, expanding cosmos. The first photons from that era still travel through space today, a faint whisper known as the cosmic microwave background, the universe's first memory. Darkness reigned for millions of years. Gravity, the sculptor of creation, gathered invisible clouds of hydrogen and helium. Under immense pressure, the first stars ignited, blazing into existence. Their light pierced the darkness, bringing the cosmic dawn. These ancient giants lived fast and died young, forging heavy elements in their fiery hearts and scattering them across the void through cataclysmic supernovae. From this stardust, galaxies were born, majestic islands of billions of suns. They swirled and collided, merging into grander spirals and clusters. Within one of these galaxies, the Milky Way, a star formed. Not the first, not the brightest, but destined for greatness. Around it, a small world took shape, blue, alive, and curious. On this planet, life began quietly, in the depths of ancient oceans. From simple molecules to complex organisms, nature experimented endlessly. Evolution sculpted eyes to see, wings to fly, and minds to wonder. From tiny cells emerged consciousness, the universe awakening to see itself. Billions of years later, a species called humanity gazed upward and asked the ultimate question: where did we come from, and where are we going? Through science, they learned that they were made of the same elements as stars, that their bones were calcium from ancient suns, their blood iron forged in supernovae. They learned that the light of the stars was older than their entire civilization. And they discovered that time itself was not absolute, that space and time bend under gravity, curving the universe's destiny. But the cosmos does not rest, it evolves. Stars burn their fuel, galaxies drift apart, and entropy, the slow march toward disorder, never ceases. Fast forward billions of years. The sun, now middle-aged, shines steadily, feeding the ecosystems of Earth. But in about 5 billion years, its hydrogen will run low. It will swell into a red giant, engulfing Mercury and Venus. Earth's oceans will boil away, its atmosphere stripped. Eventually, the sun will shed its outer layers, leaving behind a tiny hot core, a white dwarf, glowing faintly in the darkness. The story of our sun is just one chapter in the saga of the stars. Across the universe, countless suns will live and die. Massive stars will explode into supernovae, seeding space with the building blocks of new worlds. Smaller stars, like red dwarfs, will burn for trillions of years, outliving every known civilization. But even they will eventually fade. As time stretches on, galaxies will continue to move apart. The universe's expansion, driven by dark energy, accelerates relentlessly. Distant galaxies slip beyond visibility, their light stretched into invisibility. The night sky grows emptier, lonelier. Future civilizations, if any survive, will see only their own galaxy, unaware that others ever existed. After 100 trillion years, the age of starlight will end. No new stars will form. The last suns will flicker and die, leaving behind white dwarfs, neutron stars, and black holes. The cosmos will enter the degenerate era, a time ruled not by light, but by the ghosts of stars. Planets will freeze. Galaxies will dim. Occasionally, two stellar remnants will collide, releasing a brief, final blaze, a flash in the eternal night. But such moments will grow rarer, until darkness is all that remains. Then comes the reign of black holes. These cosmic titans, born from the collapse of massive stars, will devour what's left: gas, dust, and even other black holes. Galaxies will become graveyards, their hearts heavy with invisible giants. When two black holes merge, they will send ripples through space-time, gravitational waves, the final echoes of structure in the universe. Trillions upon trillions of years will pass. Even black holes, once thought immortal, will begin to evaporate through Hawking radiation. Slowly, almost imperceptibly, they will lose mass, shrinking, fading, until they vanish in a burst of energy. The last fireworks of creation. When the final black hole dies, the universe will be nearly empty. No stars, no light. Only a thin soup of photons and subatomic particles drifting endlessly through an ever-expanding void. This is the black hole era, giving way to the dark era, the age of silence. Time itself stretches to infinity, and change becomes rare. Matter may decay, protons might disintegrate into radiation. Everything solid dissolves into nothingness. Entropy reaches its peak. Energy is evenly distributed, no work can be done. The universe enters heat death, a frozen stillness where nothing happens anymore. And then, paradoxically, time loses its meaning. Without change, without motion, there is no before or after. Only eternal sameness. The clock of the cosmos stops ticking. It is a strange ending. Not a fiery apocalypse, but a quiet fade into oblivion. The story of everything ends not in chaos, but in calm. But perhaps this is not truly the end. Some scientists dream of rebirth. That deep within the quantum foam, fluctuations could spark new universes. Each one, perhaps, with different laws of physics, different constants, and different fates. A cosmic cycle of birth, death, and renewal. An infinite garden of universes. In that vision, our universe is just one flower in an eternal field, blooming, dying, and giving rise to others. Maybe in one of those universes, stars shine again. Maybe life reawakens. Maybe somewhere, something looks up into its sky and wonders, once more, where did we come from? The grand timeline of existence stretches farther than imagination. From the instant of the Big Bang to the death of the last black hole, the universe has traveled a path of transformation, from fire to frost, from order to entropy, from chaos to stillness. For now, we live in the golden moment, a brief window where stars still shine and life can think and dream. In cosmic terms, our time is but a heartbeat, yet it is everything we know. We are the universe's way of knowing itself. Through our eyes, the cosmos beholds its own creation. Through our curiosity, it contemplates its destiny. And through our stories, our science, our art, our questions, we give meaning to the infinite. When all is said and done, the universe will fade, but the echo of its beauty will endure in the brief brilliance of consciousness, a spark that once flickered in the darkness and called itself alive. The stars will die, but the wonder they inspired will not. Because even when everything ends, the story of existence and the memory of being will remain written in the quiet geometry of space-time. And in that silence, in that stillness, lies the greatest truth of all. Everything that ever was still is. For the universe, even in its final breath, carries the whisper of its beginning. Nothingness is not the opposite of creation. It is its completion. The end of time is not the death of meaning. It is its fulfillment. The cosmos began in brilliance and will end in peace. And between those two eternities and this fleeting now, we, fragile, thinking stardust, get to witness it.